So we talk about polygons, we are talking about shapes. We're talking about two-dimensional shapes. All right. As I said before, something that we should be able to draw on a flat surface. And the figures have to be, the shapes have to be closed. So of course, we're going to be looking also at examples of polygons as well as non-examples, so that you have a very clear, not just a definition, but an understanding of the proper understanding of the term. So they're two-dimensional shape, they are made up of straight lines.
And there's a lot to unpack there in that definition. So I'm going to go word by word to make sure we fully understand what it means for a shape to be a polygon. Now, the first word we come across is this word closed. And that means that the shape has to be closed. It can't be open. All the sides must connect to each other. A great example that I could show you is a square. A square has four sides. All the four sides are connecting to each other, and there are no openings. An example of a non-polygon were to be if I were to erase that top side. Notice that there is now an opening here. This left and right side do not connect. And this opening here means that that figure there is not a polygon. For it to
All right, so make sure we understand that now. In order for the figure to be defined as a polygon, it must be closed. Whatever number of sides it has, it must be closed. There can be no opening, there can be no curves, and all of that, because it has to be straight lines that close the figure. All right, so examples and non-examples. So the square was just one example. Kamisha had mentioned like triangle and so on before. Very good. The square is also an example. But if we have a figure looking like this, one side is open or two sides open, or if there's a curved side, it is not a polygon. All right. So you can make a sketch, example, the square, sketch the square, and this would be a non-example. Non-example. This one that is open would be a non-example.
be a polygon, it has to be closed. Now, the next phrase that pops up is a two-dimensional shape. And that sort of should make sense to you. We're not talking about a three-dimensional shape that you can physically hold. It has no depth, it has no height to it. It is a flat shape, something that you would write on a piece of paper that we wouldn't be able to actually pick up and hold on to. So that is the first part, a closed two-dimensional shape made up of many straight lines. One of the key parts about a polygon is that it is made up of straight lines. We're not talking about circles or ovals here. For a polygon to be a polygon, it has to be made of straight lines, not curved. Now, the other big word that's hiding in there is this word many. Now, many is actually coming from the prefix of the word polygon, which is poly. And poly means many. And that means that polygon is sort of the overarching category for all the shapes that you think of. It includes many shapes of many different lines and sizes, and that's going to be our main definition for what a polygon is. A closed, two-dimensional shape made up of many straight lines. Now, you might be thinking to yourself, okay, what are some shapes that might qualify as polygons? And I have a nice list here that shows you all the different types of polygons we could have. Now,
all right, what I want you to do now is to sketch some of these. You may not have to draw them. You won't be able to draw them accurately now, because this is showing what we call regular polygons. All right, so you'll have to be able to draw these accurately. But don't worry about drawing them accurately. I just want you to sketch, even for example, the first three. So just examples. I'll direct you to other resources where you can see these shapes another time. So the smallest polygon, please sketch the first three or four, the first four. Sketch the first four polygons for me. As I said, you don't have to try to draw them accurately. So the smallest polygon is a triangle, 3 sides. Next one, quadrilateral, pentagon, hexagon. Use your pencil and just make a quick sketch of each one. Just the first four. Alrighty, everybody?
This is not a complete list because, as you can imagine, we can go higher than the number of sides we see here. But we're going to start off with these 8. Now, the smallest polygon you can have is a triangle. That's because in order to create a closed two-dimensional shape, the least amount of sides you can have is 3. So a triangle here has 3 sides. So a 3-sided polygon, we call it a triangle. Next, we move on to the quadrilaterals. And the quadrilaterals are polygons that are made up of 4 sides. And that includes your squares, your rectangles, your rhombuses, your trapezoids, your kites, your parallelograms. All of those 4-sided shapes are going underneath that category of a quadrilateral.
All right, so for quadrilateral, we are going to be going into that in more details as well, looking at the different types of quadrilaterals. But the word quadrilateral now is the overall name, that umbrella name, the name for all 4-sided figures, whether they are parallelogram, square, trapezium, rhombus, all 4-sided figures come under one category, one name, quadrilateral. But we'll be looking at each of them in more details. So we have to see the characteristic of each one. All right, guys? Are you with me?
Yes, miss.
Now, as we move away from the triangles and the quadrilaterals, you're going to start to see a pattern with the naming scheme, specifically when we get to the word pentagon. Now, a pentagon is a 5-sided shape. That prefix pent is our prefix for the number 5. And as we move through each of the next shapes, you're going to notice that they all end with the suffix gon. And that's because we just start off each name with the number of sides as its prefix. So a pentagon has 5 sides. We then move on to the hexagon, which has 6 sides. This one you might not be as familiar with, but a 7-sided shape is called a heptagon. Then we move on to an 8-sided shape, which is called an octagon. Again, another one you might not be as familiar with, but that is a 9-sided shape, which we refer to as a nonagon. Then finally, we end here with this last shape shown here, the decagon, which is a 10-sided shape. Now,
all right, so what you can do at this stage, instead of spending the time to draw the others, as I said, you don't need to draw them right now. You could just write down the name, heptagon, 7 sides, octagon, 8 sides, nonagon, 9 sides, and so on. Just write the name and the number of sides beside each one. Ready again?
Yes.
now, there are names for shapes past a 10-sided shape, right? We can get to an 11-sided shape, a 12-sided shape, a 20-sided shape. All of those are going to have special names, but usually in math classes, we tend to just memorize these 8 here. And that's because to try to memorize all the different shapes that encompass polygons would be a lot of different names to try to remember. And so we actually have a nice naming scheme for polygons when we get past 10 sides. And what it is we just put the number of sides. Let's say I'm thinking about a 15-sided shape. Well, we would call a 15-sided shape a 15 gon. You notice that we're not using the actual prefix for the number 15. Instead, we would just call it a 15 gon, a 15-sided shape. Same thing with, say, let's say a 27 gon. That refers to a polygon with 27 sides. And so as we get past the 10-sided shape, you'll notice that all we will do is change that n value there, the n gon, where n is going to refer to the number of sides. So however many sides your polygon has, we're just going to call it that plus the ending of gon. So you could have a 40 gon, a 50 gon, 100 gon, 100 sides, 195 gon. You're starting to get the gist that as we get to these larger polygons that we really don't want to be trying to draw out, that's going to be our naming scheme. Now you might notice some very special characteristics about these polygons here. And for a fact, all of these polygons happen to be what we call regular. And what regular means is that all of these polygons here that are shown, they all have equal sides and they have equal angles.
All right, so make a note of this for me now. So skip a line, write regular polygons, and I want you to underline that or highlight it or put a bubble around it, as I say. Sometimes we do different things to highlight important information in our notebook. So a regular polygon, underline that or highlight it or put a little bubble around it and make a note that regular polygons have equal sides and equal angles. The polygon is regular. It means that all the sides measure the same length and all the angles in that polygon measure the same size. That's a regular polygon.
Now that's not something that's always true about polygons, and unless it's specifically stated that you're dealing with a regular polygon, you can't assume that all the sides are equal or all the angles inside are equal as well. But for these 8 polygons shown, I'm telling you right now that these are all examples of regular polygons. We see with this triangle that we do have an equilateral triangle. All of those sides are equal, plus all of the angles inside are equal as well. For the quadrilateral, we see that all those sides are equal. And when you have a quadrilateral with equal sides, well, we call that a square, because it's also going to have 90-degree angles in here that are also all equal to each other. And then as we move on to the pentagon, hexagon, heptagon, all the way to the decagon, hopefully we start to notice that all of these sides are equal to each other in that shape, plus all of the interior angles inside are also equal to each other because they're regular. Regular polygons have equal sides and equal angles. Now, I'm going to show you some examples of non-regular polygons, and we can see those polygons right here. We see we have a triangle, a quadrilateral, a pentagon, hexagon, right? All of the ones we've just seen.
All right, guys. So here now, we just looked at regular polygons. Can somebody remind me what regular polygons are? We say a polygon is regular. What does that indicate?
They have equal sides and equal angles.
All the sides of that polygon are the same length and all the angles are the same size. That's for regular polygons. but it's not all the time that the questions we are dealing with will be regular polygons. All right, it can be irregular or non-regular polygons, and this here now are examples of polygons that are not regular polygons. All right, so notice that this one that has a 3 sides, it is still a triangle. It's still a triangle, but it is not equilateral. The second one, 4 sides, but the 4 sides are not equal. It is still a quadrilateral, although the sides have different measurements, as you can see from this sketch. All right, again, go ahead and just sketch 3 or 4 of them.
Regular polygons have equal sides and equal angles. Now, I'm going to show you some examples of non-regular polygons, and we can see those polygons right.
All right, so we get this one now, non-regular polygons. All right, in a little while we're going to
here. We see we have a triangle, a quadrilateral, a pentagon, hexagon, right? All of the ones we've just seen in the previous slide, but these shapes here are not regular. We see that the sides are not all equal, nor are all the angles equal as well. So I just wanted to make that clarification on what it means to be a regular polygon and what it means to be a non-regular polygon. Remember, regular is going to refer to polygons with equal sides and equal angles. I hope this video helps clarify what it.
All right. So everybody clear on that now? That is an introduction, reminder for some persons, reinforcing for other persons, but you must have that information because you're going to see these terms coming up. You're going to see the names of the polygons come up. And if you are dealing with a question that gives the name of the polygon, you should have an idea of what the number of sides and whether or not the polygon is regular or it is non-regular. Everybody good on that?
Yes.
All right, I'm going to stop sharing the video now, and I'm going